Uh, my name is Renuka Badhe, and I'm the Executive Secretary of the European Polar Board, and it is really my pleasure to welcome all of you for this policy briefing today. We have two excellent speakers. First up is JB Sallée. He's our first speaker. He's the coordinator of the SO-CHIC project, which has been funded under the Horizon 2020 program from the European Commission. JB is an oceanographer and also a climate specialist that works quite a lot on the Southern Ocean. He's currently based with the Sorbonne University in Paris. And as one of the lead authors of the last IPCC report, he's absolutely the best place to give this talk today. So JB, over to you.
Thank you, Renuka. So I'll just bring up my slides. Can you see them? Okay. Thank you. So yes, thank you, Renuka. So I'm going to talk today about the policy relevance of Southern Ocean for Europe, and I will specifically focus on two aspects: climate impact and sea level rise. So as you probably all know, the Earth has been warming over the past 100 years. This warming, that's an important result of the last IPCC report, is unprecedented in the last 2000 years. We know also that this warming is due 100% to human activities. That's another big result from the last IPCC report. And that's interesting that this warming is actually faster in Europe than the global average, about twice as fast as the global average. And that means that Europe is facing a strong intensification, increase of the frequency and intensity of extreme events like extreme heat, heavy rain, drought, which impact our communities, impact our economy, and which we see more and more often in the front page of our media. But as dramatic as is this Earth warming, this increase of extreme events, we have to understand and acknowledge that this atmospheric warming is actually only the tip of the iceberg of climate change. It represents only 1% of the Earth's energy increase associated to climate change. If we have to understand the brutality and the importance of climate change, we really need to dive below the ocean surface. That's where most of the energy that is associated to climate change is stored. And if we want to understand that, we really need to go in one specific place on Earth, the Southern Ocean. That's where up to 75% of all the heat that is absorbed by the world ocean is actually absorbed in the Southern Ocean. Similar story for the carbon, up to 50% of all the carbon dioxide that is stored in the world ocean is actually entering through the Southern Ocean. So the Southern Ocean is really a door for the climate signal to enter the oceans and to be stored for a long time, 100 to 1,000 years. So really Southern Ocean mitigate climate change by absorbing carbon and heat associated to climate change. So really Southern Ocean give us a crucial service to our daily life. We can try to quantify that service. If we talk, for instance, about the carbon removal that the Southern Ocean does, we can quantify that. That's about 0.8 billion of grams of carbon per year that is absorbed by the Southern Ocean. Probably doesn't tell you much when I give you that number, but you can try to compare to other part of the climate system. For instance, you probably know that the Amazon forest is key for carbon removal by growing forest. The Southern Ocean is actually twice as efficient to remove carbon from the atmosphere. We can actually cost that service that the Southern Ocean provides us. If we take the European Union emission trading system, we've got a cost associated to a ton of carbon removed from the atmosphere, and that gives us the service that gives us the Southern Ocean of about 55 billion euro per year. So a huge service that Southern Ocean provides us. Why is the Southern Ocean so central for our climate? To address that question, we need to. I'd like to bring up this view of the world, which is probably a bit distorted to what you are used to. That's a projection which is called the Spillhouse projection, and that give the central place to the Southern Ocean. What I'm showing here with the red and blue arrows is what we call in the jargon the overturning circulation. That's the global ocean circulation that connects all basins of the world and that regulates climate on long time scale. And we see clearly that the Southern Ocean is the central key player in this circulation. And because of the hostile climate, because of the presence of ice, the ocean is very turbulent, and this turbulence allows for the climate signal to propagate deep and to be stored for a long time in the deep seas. But this service that the Southern Ocean provides us comes at a very high cost. We know today that Southern Ocean water masses are warming deep. This warming propagates across the world ocean because of this large-scale circulation. The water mass also acidifying, deoxygenating. The warming means that the water takes more volume, it inflates, and that causes sea level rise. And the second aspect that causes sea level rise is the Southern Ocean actually melts the ice cap, the Antarctic ice cap, which also add fresh water to the ocean and therefore cause sea level rise. We know today that this Antarctic ice cap is melting, specifically in some regions like the West Antarctic, but also the East Antarctic in some parts. And we know that we are risking a potential tipping point in some regions. So ocean warming and ice sheet melt, which are two critical aspects related to the Southern Ocean processes, cause sea level rise. Today, we are at about 20 centimeters of sea level rise. It might sound small, but actually already big impact on our daily life. Here I'm showing two pictures taken from European coast, floodings, erosions, and we know that this sea level rise is actually unprecedented in the past 3,000 years, so already very large. But we know also that that will continue in the future. By the end of the century, we'll be around between 0.5 to 1 meter, depending on our collective choice of emissions. And if we take the low range here, a very ambitious mitigation scenario, we know that we will have to face major challenges. Here I'm showing the amplification factor of extreme sea level events, so flooding at coast. And this amplification factor is around most of European coasts, Southern European coasts, an amplification on 100 to 500 times more frequent extreme sea level. And here I'm only showing the most ambitious mitigation scenario. We also know that the situation can be much worse if rapid Southern Ocean related Antarctic destabilization process are triggered with sea level up to 1.6 meter by the end of the century and up to 2 meter by 2150. So I'll stop here. To summarize, Southern Ocean is definitely a remote place, but we shouldn't be mistaken by this remoteness. It actually shapes our daily lives. And unfortunately, it remains underobserved, understood, and we really need to put efforts because processes in the Southern Ocean are critical to our adaptation strategy in Europe and to our mitigation strategy as well. Thank you.
Thank you very much, JB. Our next speaker is Sean Henley. For all the people who are attending, please do keep your questions ready. And once Sean finishes, then we can have a really nice discussion session with all of us. So Sean Henley, it is my pleasure to introduce her. She is currently a lecturer at the University of Edinburgh. She works in marine sciences. She's currently serving as the vice chair of the Southern Ocean Observing System. And she's also a member of the Southern Ocean Task Force for the UN Decade on Ocean Sciences. She's also been very active in the policy arena, where she's represented the Southern Ocean community in the COP26 meeting, where she convened and led a session on the Southern Ocean ecosystems and the need for protecting them. So Sean, on to you. Thank you.
Thank you, Renuka, for that kind and detailed introduction. So it's a pleasure to be here today. I'm going to follow on from what JB just explained about the Southern Ocean, and I'm going to look at the importance of these Southern Ocean processes far beyond the Southern Ocean, and I'm going to have a specific focus on what the implications are for Europe. So carbon uptake, the carbon uptake that JB just described occurs by two sets of processes. Those are the physical processes and the biological processes. And these two sets of processes account for a similar amount of that total uptake that JB described. So this image here shows the distribution of biological carbon uptake around the Southern Ocean. And what we see is that this critical ecosystem service, which the Southern Ocean provides by regulating global climate for the entire human population, this requires the natural processes that drive it to be unperturbed, or as unperturbed as possible, and for the Southern Ocean ecosystem to be as healthy and productive as possible. So this is an image of the Southern Ocean ecosystem and the ecosystem services that it provides. What we see in the center there is the phytoplankton bloom. This is the main mechanism by which carbon is taken up by biological processes, and this carbon is then transferred through the food webs in the water column and at the sea floor. And in these two food webs, this carbon can be stored over timescales of tens to hundreds of years as blue carbon, which has a negative effect on climate change and acts to mitigate climate change. So blue carbon is a primary ecosystem service. Another one is biodiversity. The Southern Ocean ecosystem makes a substantial contribution to biodiversity, both regionally but also worldwide. And that's because the Southern Ocean is very rich and very biodiverse, and also lots of the animals that we find in the Southern Ocean migrate in and out and over vast distances, and therefore what happens in the Southern Ocean does not stay in the Southern Ocean. And this food web, or this ecosystem, also underpins very significant fisheries, for example, for Antarctic krill or toothfish or the mackerel icefish. And actually many European countries have fishing operations in the Southern Ocean. So the sustainability of this ecosystem is of direct relevance to European economies and food security. But these ecosystems are under pressure from global climate change and from direct human pressures of human activities, such as fishing, transportation, pollution, the risk of invasive species. And this means that they need protection from global climate change through global climate change mitigation, and they need effective local and regional management. And a primary mechanism for this management is through marine protected areas. So this image I've got on my screen here shows the coverage of marine protected areas earlier this week, and we can see that about 8% of the global ocean is currently protected. So there was a United Nations target that 10% of the global ocean would be protected by marine protected areas by 2020. And as we can see, we are falling short of this target. There is now a new revised and revamped target to achieve 30% coverage by 2030. And this is a pledge that many European countries have signed up to. So we can see that there is a lot of work to do, but there is significant potential through safeguarding the Southern Ocean that we can bolster this level of protection at the global scale. So there are marine protected areas around some of the overseas territories of European countries. And there are also 2 high seas marine protected areas which are governed by international treaty, of which European countries play a significant part. And there are 3 more marine protected areas that are being debated at the moment. These are at the West Antarctic Peninsula, in the Weddell Sea, and around East Antarctica in the middle of the image. And again, European countries are very centrally involved in these negotiating processes through the Commission for the Conservation of Antarctic Marine Life, or CCAMLR, and indeed the EU is involved directly as an entity. So looking beyond the Southern Ocean now, we also know that the Southern Ocean holds this central place in the global ocean circulation, as JB explained. And what's critically important for the productivity and the health of the global ocean is that nutrients that are required to sustain all marine life are sourced from the Southern Ocean and distributed throughout the global ocean. So in this way, the processes occurring in the Southern Ocean actually support ocean productivity at the global scale. They underpin the uptake of carbon by biological processes in the low latitudes, and therefore support ecosystem productivity and ocean health at the global scale. And of particular interest to Europe are the very productive fisheries occurring off Southern Europe and West Africa, where many EU countries have bilateral and reciprocal fisheries agreements, and therefore the processes from the Southern Ocean that underpin these fisheries are of great significance to European fisheries, as well as fisheries from a much larger set of nations, and they are critical in underpinning large economic entities, as well as food security in Europe and far, far beyond. So the effective management and policy making around the Southern Ocean requires sustained and coordinated research and monitoring, and ongoing science to policy dialogue and translation. So the themes that JB and I have discussed here are highly relevant to lots of international frameworks, such as the European Green Deal, the UN Decade of Ocean Science for Sustainable Development, and the UN Agenda 2030 and the Sustainable Development Goals. So it's also relevant to point out the significant importance of European research funding, as well through the Horizon Europe programme, as well as infrastructure and support of the European nations themselves, but also the leading role of the European nations in the international collaborative community working on these issues. And an excellent example of that is the All-Atlantic Ocean Research Alliance, which joins the processes happening in the Southern Ocean all the way through the Atlantic and up to the Arctic. So really large scale and important alliance. So I'm running out of time, so I will just finish with my key messages that the Southern Ocean is of critical importance to Europe, despite its relative remoteness, because it regulates global climate and therefore European climate. It contributes substantially to global biodiversity and ocean health, and by doing so, it underpins fisheries and food security at European and international scales. So the Southern Ocean is under pressure, so it needs protection urgently through global climate change mitigation and effective local and regional management. And in order to afford effective protection to the Southern Ocean, we need to continually improve our understanding of the way the system works and the way it's changing. and this requires sustained and coordinated research and monitoring. And I'd like to finish by really emphasizing the fact that the European Union is ideally positioned to take a lead role across the full spectrum of these activities to deliver really significant benefits to its member states, its citizens, as well, of course, as the international human population. So I'll stop there and look forward to the discussion. Thank you.